Hello, everybody. In this short tutorial, I'm going to show you how you can use the generative design feature in Fusion 360 to get from this bulky bracket that initially you have designed to this bracket, which we managed to get 40% weight reduction. And we're going to talk how one can use additive manufacturing to make this component. But the focus of this tutorial is how you can get from this bulky bracket to this sexy bracket. Actually, I managed to print this component using a stainless steel, which I can show you. This is the original bracket. Of course, I 3D printed. You can see all the lines, but typically for a bracket with this design, we may use machining, like CNC machining, or maybe other approach like casting, depending on the manufacturing processes that we decide to use and the quantity of parts. And this is the components that I showed you later. Of course, I put it under loads. That's why it's a little bit deformed, but you see the shape of that. And these two brackets have the same functionality. And also you need to pay attention that we will keep some area preserved because those are the area that the bracket is going to sit, or other features like that. We're going to keep them. All right. So with that, let's get started. I'm going to share my screen, and then I'm going to walk you through the process in Fusion 360 step by step. All right. Sharing my screen here. All right. Let's start with the original bracket. This is the original bracket that we have. Of course, this bracket is going to be used in some applications. So there are other components around that. And there are also areas that we need to preserve. For example, I wish to keep that area preserved. Let me turn them on. I wish to keep that area preserved, maybe because they are sitting on some bearing or for other features. And by the way, this is an example that I choose here. You may choose any other example, similar examples, and do your own test for that. Also, I wish to keep that area and that area preserved. If I hide my original bracket, you see these are the area that I decide to keep them with no change. All right, so that's my original bracket. And as I said, this bracket is going to be using with other components. So there are some, let's call them obstacles, for example. And this is where the entire bracket is going to be fixed on a plate. And there are also another obstacles there. Maybe there are other features that are working with this component, maybe part of a mechanism. And this is another part of mechanism. So these are other components not related to these, but they're going to work with this component, and we're going to use them as obstacles. All right, so that's about these components. Let's start with the generative design. And also, we know that this bracket is going to be under some loads. And for loading, let me stop sharing here, and I'm going to this time share my entire screen, share. So for loading, assume that this bracket, again, is just an example that we want to use. Let's assume that there is 10 kilonewton loads there, and there is 5 kilonewton in Y direction. So 10 in Z direction and 5 there. And let's suppose that 4.5 kilonewtons there and 4.5 kilonewtons there. Right? Again, this is some numbers for these particular examples. Obviously, we can use our knowledge. This part is more like a beam, and using like symmetric, because the load is right in the middle, I can divide the force by half. So I'm going to get 5 kilonewton there and 5 kilonewton there. And I'm going to get 2.5 kilonewton in that direction and 2.5 kilonewton in that directions. 5 divided by 2, and over there 10 divided by 2. This part and that part are going to be 4.5 kilonewtons. So we have the numbers down there. All right. So these are some pre-calculations that we need. But in Fusion, we switch from design over there to a generative design. So this is the new screen there. And it's very simple. Step by step, we follow actually the things that here we need to identify. All right, so it says study 1. So I'll start by the preserved geometry, and I can turn on my model component here. So I'll see each of them there. All right, so let's start by preserved geometry. Preserved geometry, I wish to keep that area, and that, which I identified them before as preserved. So that's my preserved. Then the obstacles, my obstacles is that plate at the bottom, and then that part, and the other part over there. So that's my obstacles there. And then the next over here, I don't have any offset, but we can define offsets with respect to those obstacles. For example, if I want like 10 millimeters offset with that, I need to check that. Speaking of millimeters, make sure that initially you check your units and they are in the units that you want them to be. So for example, if it is in inch, you may change it and accordingly the rest of that. And so then original shape, or it's called starting shape. Obviously, my starting shape is that original shape that we set it there. Over here, are we going to just remove material, or we are allowing adding material as well? Let's keep add and remove at the same time, but you can try with both options. The removing material, it means you start from original and you can only allow to remove material from there, not adding, but I'll keep it add. So if you do everything correctly, now this is the color that you see. You should see yellow, which is your original. You should see the green, which is the obstacles. And you should see the red, which are, you should see the green, which are the preserve, and the red, which are the obstacles. All right, so these are the color that you see here. Next, we need to define the loading. Let's start with maybe gravity. So gravity is defined there. So you may have gravity or may not, but in this example, we have gravity there. But if you wish to change the gravity or its direction, you can set it in any direction that you want. So that's about gravity. Next, I need some constraint. Structural constraint. I click on a structural constraint, and then maybe I'll hide that obstacle. So I know that my component over there is gonna sit. Make sure that you select a plane, not edges. So these are two areas that are gonna sit on that plate and they are fixed. So that's the obstacles there. So I have my obstacles. And then loading. Let me turn off the maybe that obstacle so we can see better. And obstacle 2 and obstacle 1. So referring to the load that we had, let me just quickly show you this. We decided that we have in Z and in minus Y direction, we have that loads. All right, let's start there. I'm going to click on structural loads and make sure that you're selecting the area, and again, not edges. And since I have loads in all directions, I click there on that icon. Now I have X, Y, Z. Make sure that you follow your original coordinate, X, Z, and Y there. So we don't have any load in X. In Z direction, in Y direction, we have, according to what we calculate, minus 2,500. Let's go back, make sure it is 2,500 in a direction of negative y. And then we have 5,000 in that directions. I click OK, and I do the same for that side. I have minus 2,500, and I have 5,000 over there. So that's my loads there. And you can see those loads here. If you made a mistake and by any chance you want to change them, you just click on edit, say your unit is Newton, and the second force, I click there and it is in Newton, and it's all good there. What else do we have? We have also some loads sitting there and they are on the plane. Perhaps there are some bolts and screws fixing that and creating some loads there. Make sure that also you are selecting the area and your load is, we said 4,400. Okay. And again, make sure that you're selecting an area and the value is 4,400. Okay, so that's about the loading. And next step, of course, we need to select, and you see also we can follow on the top menus here. I'm just following these. Your design criteria. You can select a factor of safety. It's up to you. Maybe for this bracket, I'm going to select 1.5, but you can choose any other factor of safety. So are you aiming for maximum stiffness or minimum mass? I'm going to go with minimum mass. That's my criteria. And then for manufacturing, let's keep it unrestricted. So we're going to have fun and see what the shape is going to be. And then it's the manufacturing process that you wish to test. Let's select additive. You may also check casting just to compare. But to keep it simple, let's just go with, additive and also casting. Maybe I'll ignore milling for now because then we need to define a few other features. And also the overhang, let's keep them as they are, but you may change them according to what you need. So these are the manufacturing processes that I wish to try with this component. And then I'll hit, and I'll select, choose all the directions for that overhang. And then I'll click OK. Next, I need, of course, a material for this component. Let's pick, so it is aluminum. I'm gonna select that one, and let's choose maybe titanium. So I add titanium. I just drag that and I put it there. It means now my material is titanium. And remember, you can try a couple of materials there, and the analysis actually is going to compare these two for you, but it's going to take longer. For now, I just wish to keep titanium, and maybe let's just try other components. But for now, let's just keep titanium. So again, it's up to you which material you wish to try. So that's about our material. And then over here, so some pre-check. One step that it's a good thing to do, just click on study setting here. And you can check your resolution high, but I suggest for the initial test, set it not low, like maybe set it low here. Of course, the higher is going to be better, but it's going to take more time. My suggestion is try with low first, and if everything works fine, then try it again with higher resolution, then you can wait for a few hours and see the result later. So, but for now, I'll keep it low. And lastly, pre-check here to see if there is any issue. Warnings, some bodies or components are hidden. Warnings are okay. So it says some bodies are hidden. Perhaps it's referring to these obstacles, and that's obstacles. So it's better keep everything on there. Now you see the pre-check. It says it's all good. And then click on preview. So what the preview does, it's a very quick check for everything to make sure that everything is in order, and it's gonna create a general design space actually between the constraints that you put there and every other components based on the load that you put there. So it may takes a couple of minutes or maybe shorter, depends on the computer that you have, but let's wait and see what will be the result that we'll see. All right, you may turn off these actually obstacles, so you see it better. What's the result when this bar, it's at the end. I'm gonna turn off the bars. I'm gonna turn off the originals and this obstacle. So it gives us roughly the shape that we are gonna end up with. And you see it makes sense. You have the preserved area, and then this gray area is your design space that the program is going to try. Actually, this is your gravity. And don't worry if it doesn't show those loads there. You may just come down here and just click on them. So if they are there, it means you're all good. Second force, it's all good there. All right, so I'm happy with that. And now what I'm gonna do, I'm gonna go there, I'm gonna click on generate. And so it says preview is in use. Of course, should we continue to exit preview and use other tools? Click quit, so I quit. And it gives me a warning about hidden. I say continue, I'm not worried about that. And then I'll click create a study. So it's gonna take maybe 20 to half an hour, again, depending on your computers. And you can come back and see the result. But what I'm gonna do here, with the example that I tried, so you can close it. So the program is going to do its work. And it says that the thumbnail, when it generates, is going to just show you the components here on this page, which right now it's just working on it. But while it's working on it, I'm just going to show you the what I tried before that. So if everything goes well, you're going to see a page like that one. And the longer you wait, it's going to converge and you're going to see more studies there. So I'll stop it there. And there were like 6 or 7 studies. And so you can click on that one. If you want more details, click on that. So for each of your design, like let's say that one, then you can click it and you can see the shape of the component. Let's click on finish outcome. So what else? You can also, for each component, for each outcome, this is outcome 1. You see with titanium, some information like the mass, the volume, the maximum von Mises stress, factor of safety, and so on. Also, it gives you some extra information, like if you want to go with 2,500 parts, how much roughly the cost is going to be, but you don't want to take those numbers serious. It's just a comparing numbers there. You can see also the same numbers there. And another feature, as you can see, you can click on that graph and compare actually factor of safety for these 7 outcomes actually as function of mass, right? You can change, let's say, von Mises stress versus material, or the manufacturing method that you choose, or the mass, or other, let's say, parameters that you choose. So here I'll see mass on x-axis, and on y-axis I see von Mises, and it says, for example, my outcome 4 has this mass and this von Mises stress, which we are not happy. Let's switch to maybe minimum factor of safety. So maybe that outcome 3, is a better one because it has the maximum factor of safety, and the mass is small. But what about that one? Still, it passes our criteria because factor of safety is still high and our mass is minimum. But anyway, you choose whichever you want. You can compare them over there. You can export them in Excel. But let's say I'm happy with one of these. Maybe I'll go with the outcome 1. So that's my component that I wish to get. All right. If I'm happy with everything that I want, I may also check like a stress view and see the stresses on this component. May check the displacement, stress, or other information that I need. And again, let's say I'm happy with the outcome, and now all I need is that I want to export it. So I click that one, and then I'm going to open the design, which takes sometimes, and here is my design, which actually is the shape that I showed you after I 3D printed, right? Let's just quickly check our process there. See, this is the file we were doing, and they are still working. So still they are generating. See, there are 10 outcomes, and you need to be patient. Don't click on them until they're done, actually. So, and it's going to keep generating more components. And as I said, you can compare different design and get your final design, like the outcome there. You can get as many as the design that you wish. Let's say you want to also get that part. So you see it's a different shape. Let's just quickly get the outcome for that one. It's preparing. It may take some time, but while it's preparing, you see that design is a little bit different compared with the design that initially we got there, right? And this one also is keep working on it. All right. I hope it's still preparing, and it's going to take some time, which you're going to check. Well, good luck. Hope you learn how to do generative design. I suggest try it with different components. Maybe start with a bracket that you designed before, and then, of course, select some preserve area, and then select some obstacles, the area that there are other components. So you don't want to add materials that actually has a clash with those obstacles. And then select some loads, choose the materials, try several materials so you can then compare, try several manufacturing processes. And good luck if you are lucky like me and have a metal 3D printer, then in your lab or in your work. And then I tried them with a stainless steel, and I got these components. And yeah, good luck with that. I'm going to actually later post another one with another examples, and maybe one which is a little bit more interesting. So stay tuned. Have a good day.